Let's talk about data visualization in R. We'll be using the built-in dataset MT-Cars today. Let's explore the dataset first. Use the plot function to quickly make a scatter plot. The data input should be vectors. On the x-axis, I'm plotting horsepower and miles per gallon on the y-axis. Labeling the x-axis horsepower and labeling the y-axis miles per gallon. The main title of the graph will be miles per gallon versus horsepower. The plot function actually makes different types of plots depending on the class of the input. Class-dependent behaviors are defined by what are called methods. For example, the number of cylinders, the CYL column, and horsepower, the HP column, they are both currently numeric data type, and plotting them will give you a scatter plot. But if you convert the number of cylinder data to the factor data type, the plot function will automatically determine it to be a box plot. Another example is the linear regression model. The output of the linear model function is of the class linear model. The plot function, when given input data of the LM class, will plot a series of diagnostic graphs. Instead of relying on the plot function, you could also specifically plot a box plot using the box plot function. Here I'm plotting horsepower as the dependent variable and the number of cylinders as the explanatory variable. You can use the bar plot function to plot a horizontal or vertical bar plot. You would first have to calculate the y variable that you want to plot. Here I use the aggregate function to calculate the mean of horsepower for every level of number of cylinders. Then I plot the average horsepower, which is 3 numbers here, 1 for each level of number of cylinders. Note that the categories are not labeled. To label these categories, you can use the names.arg argument to specify the labels. It's best, though, to first convert the number of cylinders data to the factor data type, and then recalculate the mean horsepower with the number of cylinders as a factor. Use the levels function, which finds the levels of a factor, and give that to the names.arg argument. Now the categories are labeled. Use the hist function to make a histogram. The functions we've talked about so far are base plots. When invoked, these functions create a plotting area. You can overlay more plots or plot elements within the ranges of x and y defined by the plotting area. Here we first plot miles per gallon against horsepower, which will be a scatter plot, and then adding on top lines connecting the data points in the order that they appear in the vectors. So first we'll need to sort the data by the x variable. As we've learned before, we can do that using the order function and order by horsepower, making a new sorted data frame. This time I'm also specifying the color of the lines to be blue and the type of the lines to be 2, which is dashed. We could also overlay points, which is basically scatter plot. Here I'm creating subset datasets for each level of the number of cylinders so that we can overlay them. First, I plot the data for 4 cylinders in the color blue, and I'm setting the range of x to be the whole range of the full dataset and the range of y to be the range of the full dataset. Then I'm adding on top of the base plot a scatter plot for 6 cylinders in color purple, and the third layer will be for 8 cylinders in the color red. Since we plotted a few groups of data, we might want to add a legend. To do that, use the legend function. Specify where the legend should be at. the title of the legend, the values of the legend, and the colors of them. It's important to specify the point character to be plotted, 16 being filled in points, otherwise points won't be drawn in the legend. You can add straight lines using the appline function. Here I'm plotting a regression line. The linear model as an input would give the intercept and slope of the line in color red, and I want the line to be very thick, so I specify the line width to be 5. We can also overlay text on the plot. Here I give the x and y coordinates of where I want the text to be, and the text and its color. Now you know how to do basic data visualization in Base R. For much better customization options and cleaner and more intuitive code, you're encouraged to explore the widely used ggplot2 package.